Now let's look at some operations that we can do with sets. This will include operations such as union, intersection, complement, etc. etc. Before we get into that, I'm going to define a couple of terminologies that will come in handy. An ordered n-tuple is of the form A1, A2, A3 up to AN, is an ordered collection that has A1 as the first element, A2 as the second element, A3 as the third element, AN as the nth element. In other words, in the ordered n-tuple, as the name suggests, the order matters. So that means 2, 5 is not the same as 5, 2. This is different from sets in that in the sets, the order did not matter. A 2-tuple is 2 n-tuples are equal if and only if each corresponding pair of elements is equal. There is a special kind of tuples when n is equal to 2. We call them ordered pairs. It has exactly 2 elements. There is a first element and then there is a second element. So if I have ordered pairs A, B and C, D, these two ordered pairs are equal if and only if A is equal to C, B is equal to D. Note that the order matters. That means the pair AB is not the same as pair BA, the only exception being when A is same as B. A Cartesian product of two sets, so let's say A and B are two sets. Cartesian product of a set is a set of ordered pairs AB such that the first element comes from the first set, the second element comes from the second set. So let's look at how we write this. We write this as A cross B is the set. It contains elements of the type AB. A comes from set A, B comes from set B. Note that A cross B is not going to be same as B cross A when set A and B are different. Every subset of a Cartesian product is a relation. We'll study this more in chapter 8 subsequently in the semester, but we can create a subset of A cross B and that will give us a relation between A and B. So let's look at some examples. Let's say I have the set A that contains the letter A, the number 2 and the letter B. Now let's say B is a set that contains C, number 2, D and E. In this case, A cross B would be the pairs where the first element comes from A, the second element comes from B. And that means I will have pair of the form AC, A2, AD, AF. So these are 4 pairs where the first element is A. Then I'll have 4 that have 2C, 2, 2D and so on and so forth. Observe that A cross B in this case will have exactly 12 elements because A has 3 elements, B has 4 elements. The Cartesian product will have exactly 12 elements. B cross A will also contain exactly 12 elements, but the actual elements would be different. So in this case, we will have CA, C2, CB, and so on and so forth. Note that there are some common elements. So for example, both of them are going to contain the pair 2, 2, but it's not going to be that both sets are equal. In fact, there will always be pairs that are in one set but not in the other, unless A and B are the same sets. A special kind of Cartesian product is A cross A, where both the sets are the same. We write this as A square because it looks kind of like multiplication of A with itself. A has 3 elements, so A square will have 9 elements. Now we can take this further. We can write it as A cube, A to the power 4, and so on and so forth. A Cartesian product of n sets, we write this as A1 cross A2 cross all the way up to an, is a set of ordered n tuples where the first number comes from the first set, the second comes from the second set, and so on and so forth. So it's the Cartesian product is A1 through an as an n tuple. Each number comes from the corresponding set. Okay, so let's look at some operations of sets like union, intersection, etc. So if I have two sets A and B, union of two sets, we write this as A union B is a set that contains the elements in A and the elements in B. So if the element is in either set A or in set B or in both, we include that element. We can write this formally as A union B is a set of elements X such that X is either in A or X is in B. Note that this is an inclusive OR, and that means we are okay if the element is in both sets. We can write this in terms of a Venn diagram. It looks like this. So this part is that I'm shading will be all part of A union B. Intersection is we want to take elements that are in both sets, and so we can write intersection as the set of elements X such that X is in A and X is in B. We can write the Venn diagram for the same thing, and it would be this part that is shaded in the middle. Next, we are going to define the set complement operation. Observe that the union had similarity with the OR operator, intersection had similarity with the AND operator. Complement is the operation that is similar to the NOT operator in Boolean logic. So the complement of set S, it's denoted as S complement. We write this as S with a bar on top. This is the set that contains all elements in the universal set except those that are in S. So if I think about this in terms of a formula, S complement is set of elements X such that X is not in S but X is in the universal set. We can write this as S complement is U, the universal set, minus S, and in terms of Venn diagram, it's basically this part over here that is the complement of S. A set difference is denoted by A minus B, or we write it sometimes as A backslash B, is the set of elements that are in A but not in B. So A minus B is sometimes called complement of B with respect to A. We can write it as a formula that says set of elements X such that X is in A but X is not in B. And if I think of this in terms of Venn diagram, it's basically whatever is inside this shape that is going to be A minus B. We can extend the intersection operation to define the notion of disjoint sets. two sets are disjoint if they have nothing in common. That means their intersection is the empty set. Now, one thing we can say in this context is the notion of principle of inclusion and exclusion for finite sets. So if I have two sets A and B, if I take the cardinality of this set A union B, then I can get that by adding the cardinality of A and B. However, when I do that, I count the common element twice, so I'll have to subtract the elements that are in the common part, which is A intersection B. If two sets are disjoint, that means the cardinality of the intersection is 0. That means cardinality of the union would be cardinality of A plus cardinality of B. Once again, we have reached the check before you go ahead slide. So what I want you to be able to get from this is to be able to answer these questions. If A, B, and C contain 3, 5, and 10 elements each respectively, how many elements are in A cross B cross C? What is the minimum size of A union B, and when does this happen? What is the maximum size of A union B, and when does that happen? Can A cross B and B cross A be different? You should be able to answer questions of this sort. The answers are provided at the bottom of the slide. Be sure to check if your answers match with what is expected.